Hello everyone, this is Safwatul Niloy, and I'm the watch coordinator for OXFAM in Bangladesh. And today I'll be presenting on behalf of my three other colleagues, Rahat, Araf, Saad, and Grover. And recently we have completed the construction of Technaf Fecal Sludge treatment plant, and we just wanted to share the learning from our planning, design, and the construction phase of it. So let me just jump on the presentation straight. Those who are familiar with the Rohingya response, you might recognize the map of the 33 camps we have in Cox's Bazar, where around 1 million Rohingya refugees residing since 2017. And there is around 500,000 of host community which were impacted for the crisis. To manage the sanitation system of the camps, we have around 50,000 latrines built, and around 1,000 meter cube of fecal sludge is produced every day, with the note that it increased by 26% in the rainy season. In short, we calculate 1.5 liter per capita per day sludge generation in the rainy season and 1.2 in the dry season. To manage the fecal sludge, we have around 160 plus operational FSTP, and out of them, 3 being centralized. The first one is the FSTP1 we built in 2018. And in 2021, we did the second one in Kutupalam, and the third one in Technaf, which we'll be discussing today. Firstly, let's understand that why we thought about constructing the centralized FSTP, because in the emergency context, most often we have to take the decision that whether we should go to with the centralized or the decentralized solution. And from the experience of FSTP 1 and 2, we knew that centralized FSTP, despite of having a higher capex, it will have a lower OPEX in the long run. And it's also the same indication given the Araf study we did in 2022. It's kind of 20%. You have to trade off with the 20% high capex in terms of per meter cube sludge treatment, with having an advantage of 3 times less operational cost for the per meter cube of sludge treatment. Additionally, we can have the more control over the capacity, effluent quality, and the maintenance in the centralized system. But the key challenge in this setting, I think, the availability of the land. And roughly, we are looking for 8,000 to 10,000 square meter of land for 120 meter cube size of biological plant. However, with this recommendation, need a contextual backing with a site-specific feasibility assessment. So in 2022, we did this assessment to compare between the two scenarios. One is centralized, that the 3 camps fecal sludge will be coming to one system, or we have divided the 3 camps into 3 zones, and we plotted for 3 different treatment plants in 3 zones. And we compared between the 2 scenarios. And the summary showed us that if we construct 3 treatment plants, it would cost us 30% more and OPEX by 3 times. Whereas one of the key debate was the distant zone, whether the sludge transportation cost will impact this OPEX or not. But the assessment showed that even if there will be a bit of high fuel cost to transport the fecal sludge from the farthest point of the camps, but it would be negligible compared to the high operational cost of 3 treatment system. So from that learning, we designed the FSTP with 120 meter cube of capacity per day. So the raw fecal sludge comes from the IFSTN and the Bakutek. It goes to the anaerobic lagoon where the liquid sludge separates. Liquid goes to the anaerobic baffle reactor and anaerobic filter reactor. From there, we pump the liquid to the constructed wetland. It's a vertical flow constructed wetland. We have 3 units of it. From there, it flows to the polishing pond. We have a chlorination tank as an optional setup, but we didn't activate it yet. Then the solid sludge from the lagoon can be pumped to the planted drying bed, and it has 6 units with the capacity of 5 years to store the fecal sludge. As a byproduct from the anaerobic system, we get the biogas and also the biosolid from the planted drying bed. It's interesting to share that the past 2 FSTP, we had a gravitational advantage. That's when primary unit was in the elevated land, but this land was completely flat. So we had to trade off between whether we should elevate the primary unit by 2 to 3 meter, or we will go for the pumping arrangement. So our initial findings show that the pumping arrangement will be much more feasible for us here. So we went for the pumping system for this FSTP. Let us share a bit that on the primary treatment unit, we had a dilemma that whether we should go for the anaerobic lagoon or the planted ringlet, which we had experience from the 1 and 2. We finally chosen the anaerobic lagoon because it was robust. It can deal with higher variation of fecal sludge loading and the characteristics, which is much needed in the emergency setting. And for the planted ringlet, when we put this the raw fecal sludge on it, we saw that the plants were dying. So it's susceptible to the raw fecal sludge, and it had a long startup time. And most importantly, for the Technaf FSTP, we had a nearby community living. So we had to think about minimize the odor as much as possible through the technology selection of the FSTP. Just spending few time on the sealing techniques of the anaerobic lagoon and the constructed wetland, the planted ringlet. So we have different options and technologies to do that. For the anaerobic lagoon, we have done it with over the geotextile membrane. We put a 1.5 mm PE membrane. And on top of that, we put a brick fat soling with a 40 to 50 mm waterproof reinforced plaster. And for the constructed wetland and the PDB, we put a 60 mm macadam because the soil characteristics was not well in the side. Then we put over the brick fat soling, we did this 40 to 50 mm waterproof plastering with 6 mm steel mesh. Now, when we gave the trial run, we saw that there was leakage from the constructed wetland and the PDB's outer wall, and that actually made us think that whether we should have opted a full RCC slab and the RCC walls or not. And we don't have a specific, it doesn't have a specific answer, but I think it mostly depends on the context that where you are in. Either way, we want economic design, we want economic construction, and also the robustness, because the time for the construction we need to minimize. So often in the emergency setting, that's we have to chase. So there are a few factors we can just note it down that the components, whether they are sitting above or the under the ground, it can govern the decision. And also, will the component hold water? It should be watertight or not. The cost and time of the construction, soil characteristics, and the local availability of the PE membrane, which is a low-cost option to seal this sort of wetlands. Then lastly, the social aspect of it, the community consultation. Often we ignore this part, but it's the most crucial because in the beginning we had a restriction from the community. They were saying they were not happy with the FSTP construction. Then we had a series of consultation with them. We convinced them with our the positive impact of the FSTP and why it's needed to safeguard their public health and the environmental safety. Then we also have done a series of consultation with different stakeholders, and we have done different trainings, the hands-on trainings for the operators and the engineers. Firstly, we recently got the first test result of it. Currently, our FSTP is with 60% of its loading. It's running. Though you can see, apart from the E. coli, other parameters, though we are close by, but we couldn't reach the standard. And the standard actually for Bangladesh, it got stricter in last year. Kind of BOD went to 30, COD went to 125. So current in the FSTP, we don't have the plantation in the constructed wetland. We are waiting for the first rain. And just to note that nutrient removal is highly challenging for all the FSTP. So, but overall, we believe that our effluent quality will much improve in the next months. Finally, a few recommendations. First of all, the fecal sludge generation and the FSTP design. In terms of fecal sludge demand and the designing the capacity, we should consider carefully the future fecal sludge demand, the containment, existing containment performance, and also design in a way so that it meet the national standard. It's always better to engage local engineers, consultants for structural design to abide with the local courts and context. Quality control and monitoring is very crucial with the documentation part of it for future compliance. It's always better to put the FSTP away from the community, but often it's not possible. So it's better to make a careful balance between the distance, land availability, and technology. And lastly, the consultation with the community to aware them about the positive impact of the FSTPs. So thank you, everyone. I hope that you are having a good time at your work, and we want to recognize our collaborators. We have Australian Aid and UNHCR as a donor. Our implementing partner was NGO Forum for Public Health. We got the technical support from the Urban Waters and in collaboration with Bangladesh government and Department of Public Health Engineering. Thank you, everyone.